find an equation for the graph of the degree 6 polynomial function and also leave the function in factored form. Because the polynomial is degree 6, we know there is at most 6 real rational zeros or roots. And graphically, we can find these by analyzing the x-intercepts of our graph. So looking at the graph, notice how we have 1, 2, 3, 4 x-intercepts. Therefore, there are 4 real rational zeros or roots, but because how the function behaves, we can see that some of the roots have a multiplicity that's greater than 1. What I mean by that is, if a function crosses the x-axis, then the root or 0 has an odd multiplicity. If it touches the x-axis but doesn't cross the x-axis, the multiplicity is even. So notice the zeros at -2 and +5 do just touch the x-axis but don't cross the x-axis, which means the zeros of -2 and +5 have an even multiplicity, and because we have 4 x-intercepts, we can assume both have a multiplicity of 2. So if these two have multiplicity of 2, 2, 4, 5, 6, we have all of the real rational zeros to find the equation of our function. To do this, we'll use the factored form of a polynomial given here below, where a is a constant and r sub 1, r sub 2, r sub 3, and so on are the roots or zeros of the polynomial function. But to determine the value of a, we'll also have to identify one more point on the function. Let's go ahead and use the y-intercept, or this point here, where the coordinates are 0, -30. So we'll first find the factors based upon our roots or zeros, and then we'll find the value of a using the point here. So we'll have f of x equals a times, the first 0 is x equals -3, so the factor must be x minus -3 or x plus 3. The next 0 is -2, so we'd have a factor of x minus -2 or x plus 2. But because the multiplicity is 2, we need 2 factors of x plus 2, or the quantity x plus 2 squared. Next we have a 0 of 1, so we have a factor of x minus 1. And our last 0 was x equals 5, so we have a factor of x minus 5. But again, this has multiplicity 2, so we have 2 factors of x minus 5, or the quantity x minus 5 squared. So based upon how our graph behaves, these must be factors of our polynomial function. And now because the graph contains the point 0, -30, that means f of 0 must equal -30. So now we'll substitute 0 for x and set the function value equal to -30, which will allow us to solve for a. So f of 0 would be equal to a times, if x is 0, we'd have 3 here. If x is 0 here, we'd have 2 squared. If x is 0 here, we'd have -1. And here we'd have -5 squared. And this must equal -30. So now we'll go ahead and simplify this and solve for a. We'd have 3 times 4, that's 12, times -1 would be -12, times +25, that's going to be -300. So we have -300a equals -30. Divide both sides by -300. This simplifies to a. Over here we have +1/10. Now that we know the value of a, we have all the information we need to find a function to represent our graph. We'll use this form here and substitute 1/10 for a. I think we'll also change the order here to put the squared factors toward the front. So we'll have f of x equals 1/10 times, let's put the quantity x plus 2 squared first. Then we'll put the quantity x minus 5 squared second. Then we still have a factor of x plus 3 and a factor of x minus 1. I hope you found this helpful.